Welcome, my dear students, in Prep 3. Today we will continue Unit 2, Ratio and Proportion, and today we want to study direct variation. Okay, the lesson is direct variation and inverse variation, but in this session we will start part 1 about direct variation or direct proportion. If we have two variables, x and y, we can say that y is directly varies as x if y equals constant times x. So if you have two variables, x and y, this symbol means directly varies. Okay, so y is directly varies as x. It means that y equals constant times x. Okay, if I want to get m will be y over x. So y over x equals constant, which is, for example, m. M is any constant, but m should be any constant except 0. So m doesn't equal 0. This relation, y equals mx, we studied before in Unit 1 how to represent this relation, and we say that if y equals constant times x, the relation will be a straight line passing through the origin point, which is 0 and 0. So the direct variation relation is represented graphically as a straight line passing through the origin point, which is 0 and 0. Here, for example, if you talk about the perimeter of an equilateral triangle, if you have an equilateral triangle, we studied that in equilateral triangle, three sides are equal in length. So the perimeter of the equilateral triangle equals 3L. 3 times the side length, because the three sides are equal. So in this case, the perimeter is varies directly as L. P directly varies as L. It means P equals constant times L, and this constant here is 3. So M equals 3. If we draw this relation, for example, if the side length equals 3, it means the perimeter will be 9. If the side length equals 5, the perimeter will be 15. 7, the perimeter will be 21. Okay, so here, if we want to draw this relation, it will be a straight line passing through the origin point. This is the origin point and this is the straight line. Okay, so if we have two variables, one of them is directly proportion or directly varies as the other. In this case, the relation will be a straight line passing through the origin point. Here, for example, show which of the following graphs represent a direct variation between x and y. Look at here. The first one, we have a straight line, but this straight line doesn't pass through the origin point. So A doesn't represent a direct variation between x and y. Here, for example, we have also a straight line, but yes, it doesn't pass through the origin, so also B is not a direct variation. C, yes, we have a straight line and the straight line passing through the origin point. And here, this shape passing through the origin point, but this is not a straight line. Here, for example, we have a straight line passing through the origin. Okay, so this is a direct variation. Here we have a straight line parallel to y-axis, so this is not a direct variation. This one, of course, a direct variation. Here we have a shape, but this shape is not a straight line. So this is not a direct variation. So we have direct variation shape C, E, and G. Okay. Here we have 3x minus 5y over 3x minus 9y equals 1 over 2. For every value of x and y belongs to R positive, I want to prove that x is directly varies as y. Okay, so I want to prove that x is directly varies as y. Look at here. If x is directly varies as y, it means that x equals constant, which is m, for example, times y. Okay, so we want to prove that x equals constant, which is any number except 0, times y. Okay, let's see. We will multiply, make a cross product. So 2 times 3x minus 5y equals 1 times 3x minus 9y. Okay, so 2 times 3 equals 6. So 6x minus 2 times 5 equals 10. So 6x minus 10y equals 3x minus 9y. Okay, I want x equals constant times y. This is the aim. Okay, now I have 6x minus 10y equals 3x minus y. I want x in one side and y in the other side. So I'll move negative 10y to the right hand side and 3x to the left hand side to get 6x minus 3x equals 10y minus 9y. So we have 3x equals y. So what about x? I'll divide by 3. So x equals 1 over 3y. It means that x equals constant. 1 over 3 is a constant number. So x equals constant times y. So if x equals constant times y, it means that x is directly proportional or directly varies as y. Okay? So x is directly varies as y and the constant here is 1 over 3. Here, for example, we have property number 1. If y directly varies as x and the variable x took two values, for example, x1 and x2. In this case, we say that, and also the second variable y takes two values y1 and y2. We said that y is directly varies as x, okay, and that means y equals constant times x. Okay, so y equals constant times x. So y1 equals constant times x1 and y2 equals constant times x2. If you divide this equation by the other equation, we will get y1 over y2. y1 over y2 equals x1 over x2 because m divided m equals 1. So in direct variation or direct proportion, y1 over y2 equals x1 over x2. If y is directly varies as x and y equals 20 when x equals 7, then find the value of y when x equals 14. We have two ways. We can use the property that y1 over y2 equals x1 over x2. Okay, in this case, y1 is 20 over y2 is required equals 7. This is x1 over x2, which is 14. So if you want to get y2, I'll multiply 14 times 20 over 7. This is the first way. The second way to get the relation. How can I get the relation? We said that if y directly varies as x, it means that y equals constant times x. And if y equals 20, x equals 7. So 20 equals m times 7. So 7m equals 20. It means that m equals 20 over 7. So the relation will be y equals 20 over 7 times x. So if I want y, when x equals 14, I'll substitute here. Instead of x, I write 14. So 20 over 7 times 14. Okay, it means 40. So if here the relation is not required, but you can get the relation, or you can use you can use the property y1 over y2 equals x1 over x2 and cross a product to get y2. But in some exercises the relation is required. Like here, for example, if x and y are two variables where y varies directly as x, but not as s, not as x. Y varies directly as the multiplicative inverse of 1 over x power 3. Okay, and y equals 18 where x equals 2. I want to find the relation. This is the first required, is to find the relation between x and y, then find y when x equals 1. In this case, we can't use the property. We will get the relation at first. After we get the relation, we can continue to get y. Okay, so let's start. Here, the multiplicative inverse, here y is varies directly as the multiplicative inverse of x of 1 over x power 3. What is the multiplicative inverse of 1 over x power 3? The reciprocal, yes, x power 3. So y is directly varies as x power 3 because x power 3 is the multiplicative inverse of 1 over x power 3. It means y equals, instead of this symbol, we will write equal constant. So y directly varies as x power 3. It means y equal m constant times x power 3. Okay, we have a condition here. We have y equals 18 where x equal x. So instead of y I write 18. Instead of x I write 2. So 18 equals 8m. 18, this is y equals 8 times m. Y equals 18 where x equals 2. Y equals 18 where x equals 2. So I'll substitute here instead of x I write 2, and 2 power 3 equals 8. So 18 equals 8m. Okay, so m equals 18 over 8. 18 over 8 means 9 over 4. So m is 9 over 4. You can calculate it as a decimal, or you can write it as 9 over 4. So the relation will be y equals 9 over 4 x power 3. So this is the relation. Okay, we can substitute in this relation to get when x equals 1, we can get y if x equals 1. Okay, so when x equals 1, I'll substitute in the relation. So y equals 9 over 4 times 1. 9 over 4 times 1, it means 9 over 4, which is approximate 2 and 1 over 4. Okay, so if the relation is not required, you can use the property, or you can use the relation. But if the relation is required, you should get the relation at first, then get the required value. Okay, another exercise. If x directly proportion or directly varies as y, and y equals 2 where x equals 40, find the relation. Here also we want the relation, then find the value of x where y equals 3. So x directly varies as y, it means x equals constant times y. Okay, so x equals my. Let's substitute. If x equals 40, instead of x I write 40. So 40 equals m times 2, because if y equals 2, x equals 40. Okay, in this case, I'll substitute. So 40 equals 2m. I want m, so I'll divide by 2. So m equals 20. Go back to equation number 1. The relation will be x equals 20, y. This is the relation. Now I can substitute in this relation to get x when y equals 3. If y equals 3, it means x equals 20 times 3, which is 60. Okay, so we get the relation, then we get the required variable, which is y. Okay, that's all about our session today. We studied direct variation. We study how to get the relation between two variables if this relation is a direct variation. In next session, we will study inverse variation. Okay, thank you very much for watching. I hope you have understood. See you next session, and goodbye.